Walaikum Assalam.
Start. Yesterday we were solving questions, and this is the part that we left at. A plane is at a runway on airport. The brakes of the plane are released, and the engine of the plane provides a constant accelerating force. Okay, the force is constant. Using the following data, calculate the takeoff speed of the plane. Ignore any resistive force. So constant forward force is 56,000. Mass of the plane is this, and time is this. Now, the first two things, they help us to find acceleration. A equals to F over M. So 56,000 divided by 16,000. So zeros cancel with zeros. So 56 divided by 16, 4, 14,
3.5.
3.5 meter per second square. Now, initial speed is 0. Final speed is what we are looking for, and time is 16 seconds. Now, there's one formula that connects all four of them. And that formula is A equals to V minus U over T. There are two ways. One is that you put the values in and then move the things around. But I always prefer to make the thing that I have to calculate subject to formula and then put the values in. V equals to U plus 80, so 0 plus 3.5 into 16. So it should be 56
Yes.
meter per second. Now, define acceleration. There's a new question. This question is from May June 18, paper 42. Question number 1. Define acceleration.
The change in velocity,
No, rate of change of velocity.
rate of change. Okay.
Rate of change of velocity is called acceleration. Shows the speed time axis for the graph of the motion of the car. The car 0 to 15 seconds, the car has a constant acceleration and reaches a speed of 28 meters per second. In 15 seconds, which are here, car has to go to 28, which is
2 from above.
okay. So this is where the first dot has to be at 0, 0 because it starts from rest. Then from 15 seconds to 32 seconds, the car travels at a constant speed of 28. 15 to 32. So this is 32. And till 32, the speed stays 28. And from time 32, the car decelerates at an acceleration of 2 meters per second square until it comes to rest. Draw the graph. Now, we need to know how much time the car has to take to stop. A equals to V minus U over T, where V is 0 U is 28, A is -2, because it is a deceleration. So when it goes into the formula, it becomes minus, and T is what we are looking for. So T becomes subject, V minus U over A, 0 minus 28 divided by -2, 28 divided by 2,
Positive 14.
14. So it takes further 14 seconds. What is 32 plus 14?
46.
46. So this is 46. So this is where the car comes to rest. So all you have to do is now connect the dots. Okay. So if you draw these 3 straight lines, see how many marks do you get. So it is important that you need to know how to draw or sketch the graph. For time 15 seconds to time 32 seconds, the path of the car is part of a circle. For this motion of the car, the direction of the resultant force on the car, when something moves in a circular path,
So towards the middle?
towards the center,
Yeah, towards the center.
towards the center of the circular path, what happens to the velocity of the car? It is changing continuously as direction is changing. Although the speed is not changing, but velocity will be changing because the direction of motion is changing. Direction of motion is changing. So in this part, as you can see, that there is no acceleration that we can show over here, but still the car is accelerating. It is accelerating because its direction of motion is changing. Okay. Here's one more question. Again,
Rate of change in velocity.
rate of change of velocity is called acceleration. This question is taken from May, June 19, paper 42. So we can see there is a curve path, and then there is a straight line path, and then there is another curve path. And we are dealing with a distance time graph. It is very important that you notice that what graph we are dealing with. Okay. Describe the motion of the cyclist. Now, listen, when it is a distance and time graph, I should make a note at the right. And this can be in your head only, that the gradient represents speed. So if I see increasing gradient, it means increasing speed. If I see decreasing gradient, it means decreasing speed. So from t equal to 0 and t equals to 15. Okay, this is t equals to 15, t equals to 0. What is happening? Like, sorry. Now, it is clear that we are dealing with a curve graph. So it is a curve graph, not a straight line. It means the gradient is not constant. Now, whether the gradient is increasing or decreasing, how can we check? in your mind, what you can do is you can make some imaginary x-axis and ask yourself what is happening to the angle with x-axis. Is this angle increasing, decreasing, or staying constant? Remember, this angle is actually what we call slope. Only for math nerds, if this is rise and this is run, how do we calculate gradient? Gradient is rise over run. But if you see it as a point of right angle triangle, we are doing perpendicular over base, which is tan theta. So actually the gradient equals to tan theta. And gradient and theta are related to one another. So if the theta is increasing with the x-axis, it means the gradient is increasing. So describe the motion of the cyclist in the time 0 to 15 seconds. I would say the cyclist is
Increasing.
accelerating. Cyclist is accelerating. Speed is increasing. Now, 15 to 30 seconds. I can see from 15 to 30 seconds, there's a relatively straighter path. And if I make the false x-axis at different position, I will see that the angle is not changing. So it means
Constant.
angle is constant, gradient is constant. Constant speed. And from t equals to 30 to 40 seconds, I can see the gradient is gradually decreasing. I hope you can see that this angle is very
Yes.
large, this is small, this is very small, and angle is decreasing. It means gradient is decreasing. So decreasing speed, deceleration. Calculate for the 40 second the average speed, the maximum speed. Now, average speed is total distance divided by total time. What is the total distance traveled by the cyclist?
300 meters.
So he travels a total distance of 300 meters in 40 seconds. So it is 7.5 meter per second. Average speed, maximum speed. So the maximum speed is like, listen, in the first part, the speed was increasing and then it became constant and then it decreasing. So it means the speed was maximum for the portion when it was constant. Okay. So if we find gradient of this portion, this will be rise. This is 50, 60, 70.
70.
70 to 250. So it
Yes.
will be 250 minus 70.
180.
And the run will be 30 minus 15. So maximum speed will be
12.
250 minus 70 divided by 30 minus 15. 180 divided by 15. So 12 meters per second.
Yes.
Please check with the calculator.
Yes, it's 12.
So this is how we can solve these kind of questions.
Oh, sir, the
Okay.
maximum speed is when the speed is constant, right?
In this case, yes, it is. Listen,
Okay.
in the first part, I hope you can see speed is increasing.
Yes.
At the end of the first part, because speed kept increasing, at the end of that part, speed has to be maximum.
Yeah.
So
Okay.
speed becomes maximum and it stays that same speed till the 30th second. And at 30th second, the cycle starts to slow down.
Okay.
So it
Thank
means
you.
between 15 and 30, the speed will be maximum. Now, this was because some of the students said that they had difficulties in graphs. So we did more graph questions. So any other question in your head that you want to discuss?
Circuits, if you're talking about topics.
Yes, we can discuss circuits. We haven't started the proper course. So yes, we can discuss any topic that you want to. But we can have a separate class tomorrow for circuits.
Okay. No problem.
Anything related to this thing? Anything related with this portion? We can do some past paper questions that are from other topics. For example, this is from energy and work done.
Okay, sir. Let's do it.
A force is used to move an object from Earth's surface to a greater height. Explain why gravitational potential energy of the object increases.
Because as it's moving higher, it's
Yes,
moving away from the ground.
yes.
And
Work
so,
done on the car. Work done on the car while did he say car or object?
object.
Work done on the object while moving away from Earth is stored as gravitational potential energy. So, gravitational potential energy increases. Shows a train moving up towards the top of the mountain. The train transports 80 passengers, each of average mass 65 kg, through a vertical height of 1600 meters. Calculate the increase in gravitational potential energy. How many of you can do it?
Teacher, do you do 80 times 65 to get
Okay,
the
total mass
total mass? Then just multiply by the height.
and gravitational acceleration.
Yeah, 10, right?
So 80 into 65 into 10 into 1600.
It's 83 million 200,000.
80 into 65 into 10. 83.2 million joules or megajoules. The engine of the train has a power of 1500 kilowatt. The time taken to reach the top of the mountain is 30 minutes. Calculate the efficiency of the engine. Work done by engine equals to power multiplied by time. So power is 1500,000 into time is
30.
30 into 60. Remember, time has to be in seconds.
Ah, yeah, seconds. Okay.
So we have 18 multiplied by 15, which is 270, 1, 2, 3, 4, 5, 6, 7. Did I get it right?
Yes.
The zeros are like 8 zeros are there?
7 zeros.
Okay, I got 8
So
zeros, then I'm there. 270 millions.
yes.
Efficiency is the useful output, which is 83 million and 200,000 divided by 270 million. What do we get? 5 zeros cancelled by 5 zeros.
It's 30.8%.
0.308. You can either write it 0.308, that is okay, or 30.8%. Okay, efficiency
Okay.
can be a fraction as well. Okay, he never said
Okay.
percentage efficiency. This is efficiency and this is percentage efficiency.
Okay, sir.
Okay, let's see, we have one more energy question. State one advantage and one disadvantage of using wind turbine as a source of electric energy. Advantage:
It's renewable.
free of cost, no carbon footprint. Okay.
Okay.
Disadvantage: occupies a large area, depends on flow of air, wind. Okay. If there will be no wind, it will not produce electricity. Now, the wind blows at a speed of 16 meters per second toward the turbine blades. In 1 second, a volume of 24,000 meter cube of air passes through the circular area swept out by the blades. The density of the air is 1.3 kilogram per cal. The mass of the pass through the circle swept area by the blade in 1 second. In 1 second, volume is this. Mass equals to volume multiplied by density. So 2400, sorry, 1000 into 1.3.
31,200.
kgs. Now, the kinetic energy of the mass of the air that passes through the area served by the blades. How do we calculate kinetic energy? Formula for kinetic energy is half mv square 1 over 2 into 31200 into 16 square. So okay, 3.99 megajoules. Suggest why some of the kinetic energy of the air that passes through the circular area moved by the blade is not converted into electric energy.
Because it's converted to other forms of energy, like heat and sound.
Listen, the air that after passing the through the blades, the air kinetic energy is not reduced to zero. It still has some kinetic energy in it.
Okay.
Yes, kinetic energy is not reduced to zero when it passes the blades of wind turbine. It still has some kinetic energy in it. So not all the kinetic energy is converted.
Teacher,
I
can I
think,
come 2 minutes? I need to use the bathroom.
sorry?
I need to use the bathroom.
Okay, okay. Just 1 second.